So moving on to our next page, of course, we're going to shift these around too. Let's remind ourselves of the different features of each of our function equations and what things do. Let's first talk about our A. So when we talk about A, we can talk about whether or not we have a stretch or a compression. This is what makes the graph either tall and skinny or spread out and wider. If A is bigger than 1, then that's when we have our stretch. If the absolute value of A, if we have a fraction here, that's when we have a compression. Don't forget, if A is negative, that's when we have our reflection. Okay? So when we have our value that's inside with the x, remember it is not true to sign, it is naturally negative. And this is where we have our left-right movement. So our H tells you how far we move left or right. And remember, if it's positive, it's going to move left or in a negative direction. If it's negative, it's going to move right or in a positive direction. All right, lastly, when we look at K, our K is a conversation of our vertical shift. So we can make it bigger, smaller. We can move it left, right, or we can have a vertical shift of up, down. If K has a positive value, it's going up. If K has a negative value, it's going down. Guess what? For the cube function, it's going to be the same. So whether I have a square root or a cube root, these values are still going to be the same. Remember, the only difference between your square and cubed graph, your square root doesn't have any negative values. It doesn't have any tails because you can't take the square root of a negative number. Our cube root, however, is allowed to be negative, so we can have output values that are going to be negative. All right, let's talk about some examples. So when we look at this, how does the graph g of x is equal to negative x minus 3 plus 2 move from the parent function? So our parent functions are on the other page. That is our basic function, and our parent function of our squared graph looks like this. So I know right away by looking at my A, I'm going to have a reflection. And that is a reflection over the x-axis. So instead of my graph looking like this, it's going to be underneath the x-axis like that. I know that my graph is going to be moved 3 in the positive direction. I know that my graph is going to be moved 2 in the positive direction up. So if I were to look at how this graph was going to go, this negative graph is going to be moved to the right, 1, 2, 3, up, 1, 2, but still have that reflective nature as a sketch. All right, now we'll look at our cube root function. When we have a quarter of the cube root, we can look at each of these different things in comparison to what we have as our parent function of the cube root that looks like this. So when I look at my 1/4, I know is going to be a compression, meaning my output is going to be 1/4 of what it normally is. So this graph is actually going to be very hugged close to the x-axis. When I look at this, I know that I am going to be moving backwards 3. So I'm going to be moving 3 to the left. And what I'm talking about moving is this center point is going to go 1, 2, 3 and be moved to the left 3. So if I sketch what this graph is going to look like, if it's moved to 3 to the left, that means it's hugging the axis very tight, and off it goes. Keep in mind, anytime you're not sure of what's happening, you can always graph your parent function and then take a look at your new function to see what the difference is. So we're going to go ahead and say 1/4 of the cube root of, we'll say x plus 3, making sure that my plus 3 is underneath my radical, and then I can see here it is hugging the axis. It crossed the axis back here at 3, but my output is 1/4 of the size that it normally is because of that compression. Alright, so now we're going to do some graphing. Graph each function, clearly mark at least 3 to 4 points, or 3 to 5 points on the graph. Make this straight for you. Alright, so I know that my graph is going to have a stretch of 3, and I know that my starting point means that this graph is going to go to the right 1 and it's going to go down 4, which means my starting point is at over 1, down 4. Over 1, down 1, 2, 3, 4. I know it's a square root graph, so if it's a square root graph, I know it's going to be this pattern. When I look at my transformations, I have a stretch of 3, and I have a horizontal shift to the right 1, so to the right 1, and I know that I'm going to be coming down 4. So when I go ahead and I look at my starting point, I know that I'm to the right 1 and I'm down 3, and I know that my graph is going to be taller than it normally is. So when I have my starting point, I can go ahead and put 1, -4 into the graph. So 1 minus 1 is 0, square root times 3, down 4. When I go to find my other points, I'm going to go ahead and go to my graphing calculator and take a look at some other options. 3 times the square root of x minus 1. I'm going to make sure that's underneath the radical sign inside the parentheses, minus 4. When I go to graph, there's where I said, and see how it comes up higher? So when I go to my table of values, of course I have errors. And so here's my 1, -4, and I'm going to have a point at 2, -1, and at 5, 2, and at 10, 5. So when I go to graph those points, over 1, down 4, over 2, -1, over 5, up 2, and over 10, up 5, I can see that stretch of 3 made this graph a whole lot taller. Alright, so let's check out the back. Here's our cube root function. So I know when I'm looking at the cube root, I know because this is a cube root, my graph is going to look, I'm going to have a tail and a top. But interestingly enough, it's going to be negative. So I know I'm going to have a reflection. And I know that my graph is going to move up positive 2 because of this. Now my center point isn't changed left, right. So 0 is still going to be where that center point is, but then of course it's up 2. So I know I can graph over 0, up 2. Now keep in mind this reflection, instead of my graph going from small to big, it's going to be the opposite of it, where it's flipped over the x-axis. So you take this and you flip it. Okay. If you want to get some more specific points, go to your graphing calculator, and you want the opposite, go to math for the cube root of x, close your parentheses or arrow out of the radical, plus 2. When I look at my graph, I'm not surprised to see it coming this way and ending, and look, there I have my up 2. So if I want to graph some points, I can go ahead and create an XY table, and I can see we need some positives and some negatives. So let's see, we'll have negative 8, 4. Skip all of the irrational numbers and stick to the integers. So I have over negative 8 up 4, over negative 1 up 3. Here's my center point, over 0 up 2, over 1 up 1, and 8, 0. So there I have my cube root graph that's a reflection and moved up 2. Okay, so these next two are kind of interesting. You can look at these two graphs, and I know right away here's a square root, and I know right away here's a cube root. Think about how I know that. Here I have my starting point, and here I have my center point. So I should be able to write an equation, f of x is equal to, for each of these graphs. So when I look at this, my square root graph, I don't think I have a structure or compression. We said that a was equal to 1, so that means we won't have to worry about this coefficient here. So when I look at where has my graph gone, it looks like I have moved back 1, 2, which means that x has been changed by a value of 2. And I know that my graph is 1, 2, 3 higher, so it comes up 3. Now, I know I said that a has a value of 1, but if you read this carefully, it says the absolute value of a is equal to 1. And I know that that means that this can have a negative because this is it's decreasing as we go. So I know it's a cube root graph, and here's my x. Let's talk about the changes that it's made. This x, instead of being at 0, 0, has come over 1 for the center. That means that that minus 1 is under the radical with the x. I see that my center point is up 1, 2, 3, so we're going to add the 3. So we had the reflection, the horizontal movement to the right 1, and the vertical movement up 3. And I love this sentence. Your calculator is your greatest tool that you have. Always put your equation and double check.